Hello, this is Ralph Alvarado, and welcome to Exploratory Text Analytics. In this video, we're going to introduce this week's content with a little lesson on meaning, probability, and significance. We're going to, last time we were focusing on the structure of textual data and different forms of data and so forth. And this module, we're going to kind of go back up the ladder of abstraction and kind of look at the project we're engaged in and look at some of the foundational techniques in the field for solving this problem. In a way, what we're doing is we are moving, so we've talked about models of text and we've talked about models of language, and now we're going to be talking about not models of culture per se, but we are going to get into the area of culture and how we can think about cultural content, meaningful content in textual material. So let's frame this by talking about the problem of meaning. So recall that in Paul Ricoeur's view, a text is something that has been removed from the situation that gives discourse its meaning. So the idea is that utterances are what give language meaning. It's when we actually say something in a particular setting to an audience that words and language has meaning. But when you have a text that's been materialized in a document and it's separated from that situation, meaning goes away, and what you have left are what Paul Ricoeur somewhat mysteriously calls non-ostensive meanings. Now, Shannon, recall, the first thing he does to situate and to solve the communication problem is to say that meaning is irrelevant to the engineering problem. Basically what he does is replace the problem of meaning, or the question of what a text means, with what the probability of a text is, and to infer state machines or language models from observed probabilities. So he basically, whereas Ricoeur says, meanings are absent from a text and all that you have left are these non-ostensive meanings, Shannon replaces that notion with the idea of probability. Now, what I want to ask is, are these things really that unrelated? Is information and meaning really so far separated? In today's reading, Turney and Patel's From Frequency to Meaning argues in the affirmative that they are actually related and that we can think about them related in a particular way. Statistical patterns, they argue, of how words are used can be used to infer their meanings. In other words, the way I like to think about it is that significance, that is to say statistical significance, may be a proxy for meaning. And what they introduce is something called the statistical semantic hypothesis, and here's a slightly revised version of it. In this hypothesis, they're simply saying that if the frequency of a signifier is equal to the frequency of another signifier, then the meanings of those two signifiers probably are the same. So a frequency refers to an observed probability distribution, and SR and SD stand for signifier and signified. This actually is a term that, again, comes from Saussure, from whom we got Long and Perroll earlier. The idea that language and all systems of meaning consist of a series of signifiers and a series of signifieds. So in a sense, what they're saying is the statistical patterns or traces left by the act of signification, and that's what you can think about writing as. Writing is through ink or through other kinds of impressions, if you will, onto a text or a document. The statistical patterns of those traces must reflect the statistical patterns of the references that motivated those traces. It's a very simple idea, and it's actually simplistic in a certain sense, but it's got a lot of it's got an important grain of truth to it that we're going to try to build on, at least as an hypothesis. The way I like to think of this, and we'll get to this in a second in a following slide, is when you think about references, that is to say the relationship between a word and something in the world, don't think about the reference as like an arrow pointing from the word to something in the world. Think about the word itself as somehow the effect of the thing in the world, the material sign as an effect of the thing in the world. And that sounds a little mysterious, but I'll give you an example of what I mean by that in a second. So Turney and Patel ascribe this statistical semantic hypothesis to ideas such as those of the philosopher Wittgenstein, You don't need to have read Wittgenstein, but basically he's famous for introducing a theory of meaning, which is that the meaning of a word is how it's used, as opposed to what it refers to in the world. Wittgenstein is famous for writing a philosophical essay, the Tractatus Logico-Philosophicus, which argued that language is like a picture of the world, and later he completely disagreed with that idea. In the second half of his life, he devoted to developing another theory of meaning, which is that the meaning of words is how they are actually used. He actually thought of words as tools and not so much as pictures or mirrors of the world. But it still helps, even with this idea and this movement away from meaning that Turney and Pentel are building on. I still think it helps to think about language in the context of reference, and to build on Ricoeur's notion of non-ostensive reference. And let me try to explain what I mean by that. So here's a classic semiotic triangle. This comes from a book written in 1923, paradoxically titled The Meaning of Meaning, from Ogden and Richards. It actually refers to something called the semiotic triangle that goes back to St. Augustine in his essay on interpretation. But most theories of linguistic and semiotic meaning build on this triad. And essentially all it does is refer to three pretty simple things. The first is the symbol, and that is the material thing or the image that stands for something. And it stands for two things, or it's connected to two things. On the one hand, it stands for something in the world, here called a referent. And on the other hand, it stands for an idea of the thing in the world, a psychological fact called the thought, or the reference here. This particular terminology we don't have to stick to, but the division between these three domains of the material, symbol, and of the thing in the world, and the idea of the thing, that's the essential part. Now with writing, what we have is a split right down the middle of this relationship. So we have the signifier, which is the symbol, and that's what I was referring to earlier in the restatement of the statistical semantic hypothesis, and we have the signified. So when you have a text, both of those things are absent. The actual thought or reference that the words referred to, and the referent, the thing in the world, are gone. Again, we don't have anything there. We have the text, and we have to infer the signified from the distribution of the signifiers. And here's what I want to introduce as a kind of metaphor to help you understand this notion of reference that I have, which is how a set of signifiers can be seen as the effect of the signified, which can be seen as a cause. And so the idea being, even though the signified is absent, if we assume that the signifier is caused by the signified, that the traces of the statistical pattern of those traces might reflect the things that caused it. Well, that may sound complicated, but here's an example. So this is a photograph. This is precisely not a photograph. It looks like a photograph of the United States, but it really isn't. It is a visualization of some data. And what these data are a collection of tweets and photographs. I'm blanking on the photo website, the famous one. And it's just a collection of tweets and photos, the geocodes of all of those. So every tweet, pretty much every tweet in Twitter's database has a geocode associated with a tweet, and every photograph in Flickr, that's what I was talking about, has a geocode as well. And what this artist has done is taken the geocoded data and simply plotted it in a two-dimensional space using the geocodes, and voila, it looks like a photograph. And in fact, it is a photograph in a sense. But notice how these points were produced by an event, an actual, almost something like the context of an utterance, taking of a photograph, and literally an utterance in the form of making a tweet. And one of the incidents of that, one of the features associated with that event, is then just mapped, the distribution. And what you have is a representation of the situation in the aggregate of what produced those things. So here we have an example of how the signified can be the cause of the signifier, and give us a sense of what the signifiers stand for. I hope that makes sense. It's not too crazy philosophical, but I think, to my mind, this is a really illuminating analogy. So let's jump ahead now to something more mathematical, something more in line with what we're going to be working with. Here we have a famous diagram from Loon from a 1958 paper where he traces out the goal of the statistical analysis of words and how one might use statistics to help get at meaning. He's got two curves here. The first one is just the non-dotted line, the solid line, is a distribution of words by rank order. So as you go to the left, you have words that are very, very frequent. These are stop words and common words, as arrow points to. And on the right, we have a classic long tail distribution of rare words. So most texts, as we're going to see, have a lot of words that appear very few times. Many, 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 many words appear just once, and many words appear twice, and so forth. So you end up with a distribution like that. So you can imagine that if you want to find those words in that distribution that are most significant, that are most discriminative of a text and or somehow are more likely to tell you what a text is about, they're probably going to be in the middle. They're not going to be the common words because they exist everywhere, and they're not going to be the rare words because they exist only in one or two documents. They're going to be words that are in the middle, and it's going to be words in combination as well. They're going to give you a sense of what a document is about. And that's what the author calls the resolving power of significant words, or what we can just call significance. And so one of the goals of this module is to look at different ways in which people have tried to estimate and get at that curve, that dotted line curve, or something like it, using various statistical techniques to somehow get and stand in as a proxy for the meaning of what these texts are. So I'm going to give you three different approaches here. There are others as well. And we're going to go over these, the first two in this module, and the third one we're going to go over in a later module. The first one is just looking at global term frequencies, which are more or less easy to compute. And this is all under the category of Zipf's law. And all we're talking about here is the idea that the term frequencies in a corpus follow a universal pattern. And based on this pattern, we can infer significance from terms, and I'll explain what that means. But essentially, the previous graph was showing this idea that the power distribution is effectively Zipf's law, and by manipulating that distribution, you can approximate what that significance curve looks like. Another well-developed hypothesis and approach is what's called the bag of words hypothesis, as Turney and Pentel refer to it as an hypothesis. And this is the idea that it's the frequencies of words within documents that characterizes the content of those documents and can be used to group documents by similarity and other things. So we can talk about documents of being about similar things by virtue of this common set of frequencies of words in the documents. And we're going to go into that in much more detail here. Here I have a side note saying, I have not been able to track down the origin of the bag of words hypothesis. No articles or texts that I've seen describing it give an actual origin, but it's interesting to note that there is a game out there called the Bag of Words game that apparently was first developed by a Dadaist poet named Tristan Tzara. I just throw that out as an interesting side note. There is also the distributional hypothesis, which is commonly associated with the word-to-vec algorithm, and we're going to devote a module to that. And this is the idea that terms that occur in similar term contexts, such as sentences, will tend to have similar meanings. And this is attributed to the linguist Zelig Harris, but also to J.R. Firth. So let's look at Zipf's law real quick. So Zipf's law was one of the first statistical patterns discovered in corpus linguistics or text linguistics. And basically it argues that there is a power law distribution of terms by frequency. We'll go more specifically into what that power law looks like in a second. It was developed by George Kingsley Zipf in 1935 in a book called The Psychology of Language. This distribution that he discovered has since been discovered to be pretty much universal, but it's still not well understood in terms of what motivates it. In my view, it probably has to do with network theory, because power laws describe scale-free networks. I'm just going to throw that out and not develop that further, but I think it's an interesting line of research to pursue. The law is essentially this. The frequency of a word, how often a word appears in a corpus, is inversely proportional to its rank. That is to say that there is a constant that is the product of frequency and rank. So the point being that the first word is going to have the highest frequency. The second word is going to have half the frequency. The third word is going to have half of that frequency, and so forth. This idea that it's a kind of a decay. What's the word I'm thinking of? A kind of a half-life decay of meaning is the essential idea behind Zipf's law. Here's an example that we're going to look at in our notebook at the end of this module, which describes this. These are words that come from the corpus that we created, the data model edition that we created last time. And you can see that the most frequent word here is the, second most frequent word is of, and so forth. And here I have selected, just as in the Manning and Schutz section that I asked you to read, I've selected ranks that are in the first level between 1 and 10, and then they're 10, 20, 30, and then they go up to 100, 200, 300, and then they go up to 1,000, 2,000, 3,000, essentially orders of magnitude. And you can see that as the words increase in rank, they decrease in frequency. And what the Zipf's constant, which is simply the rank times the frequency, shows is that the constant looks like it might approximate that significance curve that we saw in the previous slide. You can see how instead of bunching up at the ends, it's bunching up in the middle. Its maximum is in the middle. But it's still not quite right because it's skewed too much. It's skewed right, as it were. And the maximum is, from this diagram or this table, you can see that it includes stop words as being most significant. What we'd really like to see is maybe that darker stuff in the Zipf-K column bunching up around, say, the 500 or 600 mark. That would be more in line with what that diagram was showing. Here's another look at Zipf's law with respect to the corpus that we have and that we're going to look at again this week in this module. And you can see that it follows a power distribution just like the first diagram showed. And here we're going to scale this logarithmically. Now, according to Zipf's law, if it were literally true, those words would align perfectly along that straight line, but they don't. They're a little bit pushed upward. And there are more recent advances on Zipf's law that we can go into, but we're not really going to do that. They account for this slight difference in curvature. Here is a histogram of Zipf's constant. So what we've done is simply looked at the frequency with which the certain values of the constant exist. And it looks like, this is another way of looking at the diagram I just showed you with the green shades in the table, that the Zipf's constant is getting at significance, but not necessarily doing a super great job of it, because it includes, again, a lot of things that are probably not significant or discriminative, a lot of stop words. But this is just a quick look at how at the direction we're trying to go. So with regard to the rest of this module, here's what I plan to do, and also I'm situating it with respect to the rest of the course. So you can see that what we're looking at here, is we're looking at the locutionary dimension of discourse. The illocutionary stuff we're going to talk about later when we get into sentiment analysis. But when we're talking about locution, we're talking about the meanings of words and the meanings of sentences. Since that is absent from the text, we have to resort to the statistical semantic hypothesis. And there are a number of ways of interpreting that hypothesis. The two items here in green squares are ones that we're going to take up this module. So that's Zipf's law that we've just looked at, but also the bag of words hypothesis that we're going to look at next. And then there's the distributional hypothesis that we're going to look at in a later module. But I'd also point out to you there's another approach too, which is to look at words as a network and use graph theoretical approaches to understand meaning. And here we would be looking at the mutual information between terms by virtue of their common participation in a document. So we're not going to go into that, not enough time in this course. So once we get done with the bag of words hypothesis, we're going to be looking more specifically at a very important metric called TF-IDF, or term frequency inverse document frequency. I'm going to show you a variant of that called term entropy, because the two are related, but it's not as easy as one might think to replace term frequency inverse documency with term entropy, but I'm still going to show it to you. And then we're going to conclude by looking at the vector space representation of the bag of words and the statistics derived from the bag of words hypothesis, which we'll set up next week's or our next module on similarity.